what's it called? It's the object they use to make shapes.
Yes, I got you. So
I use that with an attribute of shape, and then I added plane as the shape, and then I use that.
that's one way to do it. But what I was hoping you would do is jit.gen, and we'll make a jit.world here to make our life easy, and we'll call it class space. And this is supposed to run out to a jit.gl.mesh in class space with a draw mode of trigrid. Right, so this is the idea, and then inside here it's expecting some matrix to come in and then derive what it's supposed to do from that. And what we want to do, right, is we want to make something that goes onto a mesh, and we want to line up the points from -1 to +1, both on the x-axis and the y-axis. So we know the S norm, if we pass it a two-dimensional matrix with 3 planes, we'll put across the x and y the appropriate value. So let's just do this. Maybe that wasn't clear, but you'll see the result. So jit.matrix, and this plane is, how many points are we supposed to do?
It's 10 by 10.
10 by 10.
So a 4-plane float 32, it's 10 by 10. And so when I put this into the jit.gen, what's supposed to happen, right, is that this matrix with 10 by 10 will run into this S norm. So S norm knows what to do based on this incoming matrix. And it says, okay, well, you have 2 things there. So across the X, going this way, I'll say, going this way, you can see my mouse. Going this way, you can see 0 to 1, and then going this way, you can see 0 to 1. So on the X plane, we'll have 0 to 1, and on the Y plane, we'll have 0 to 1 across 10 cells. Right, and here we have the plane. Probably easier to see the result in polymode 1.1. So look at the lines of this. There they are. And we're a little bit too close for comfort. So I'll just move this plane back a little bit so we can see it a little better. There it is. So this is the inside of the gen. Not much there. -1 to +1. I guess what would happen if we did norm?
Wouldn't that go from 0 to +1?
Right, so we would expect this to be in the first quadrant, geometrically speaking, or the upper right. That didn't do what I expected it to.
You gotta rebang it. Yeah.
There we go. So there it is, and if we zoom in a little more, we can see that it's basically up here in this quadrant. So S norm is the proper thing to use here because we do want it to go from -1 to +1. And that's what it's supposed to look like.
I realized that I did something completely different. I used jit.gl.grid shape.
Yeah, and that's actually another solution, and not a bad one. So jit.gl.grid shape at shape plane at dim 1010.
Yep, that's what I did.
At output matrix. Is that a thing?
Yes.
Yeah.
One output matrix.
Output underscore matrix, I think.
It's just not happy with me. Well, pit output whatever. Output matrix 1.
Yep.
Okay, and now we're going to bypass all of this. We're going to put this here, and then it needs a bang. Whoops, a bang.
It's matrix output 1, no underscore.
Okay, there we go.
Oh.
Okay. And then we get the same
That's for the
thing,
match.
right?
Yep.
And we could actually position. I'm not sure if this would work. Let's find out. So we could position either one here. maybe. No, that doesn't work.
I use scale, which I guess is probably not correct, but you're able to just zoom in and out by shrinking or expanding the object.
Sure. So here, what's happening, right, is the same thing as what's happening here. Right, this is the same thing. And in fact, there's a third way to do this, probably, which would be in jit.gen. I would imagine there's a thing called plane. That would do that, right? So it did put out a plane, but you know where it's located is a little funky. Looks like it's normalized, right, to 0 to 1.
Dr. Thompson, I have a question. So
Yes.
the grid shape object, I think when you did that, it like automatically centered. Is that? Yeah.
Yeah, that's interesting, actually.
I'm surprised you didn't have to go through the gen with SNorm to do that.
I'm surprised too. But yeah, it looks like this one's -1 to +1, whereas this one in gen does something different. So just a different way of calculating the stuff. It may be the case that I could maybe just scale what goes from 0 to 1 to go to -1 to +1 here. And maybe that would solve our problem. Yeah. So different ways to go about doing that. The preferred way was to use the gen object just to become familiar with gen because it becomes a useful way of dealing with things. But there's other things you could do there. What's interesting to note is that even with a three-dimensional object, we're still using 2 planes to do this, right? Or sorry, a 2-dimensional matrix to do this. And it looks like sphere would have been centered without the scaling. But you could also do that with the grid shape. Okay, so there's those things. All right, so I wanted to cover something that's going to kind of hit on this territory, and I'm just going to move on for now. And I'll look at your tasks, and I'll tell you, I'll give you helpful tips, hopefully, about how to improve your life. I've decided that we'll do the midterm actually with a technical portion, and we'll have a historical portion as well. And I might do that on 2 different days next week. I don't see the need to do that in real time, so I would like it to be take-home. And that'll make your life a little bit more investigative than consternative, if that's a word.
Stressful.
Stressful. All right, so don't say this. All right, so today what I wanted to do is we just looked at something quite interesting, in my opinion, which was how to use gen to generate points. So I want to talk about this jit.gl.gridshape. My class at shape sphere. And I'm going to scale this down to 0.1. For clarity, I'll put in 3 of these. All right, so there's a grid shape, and I need a jit.world.
I have a quick question.
Yes.
The matrix output attribute that we were using,
Mm-hmm.
what exactly does that do and why is that important?
Well, normally what happens, right, is right now when I do this, there's going to be a grid shape in my space because it is on the graphics card speaking directly to this memory space, or this render space. If I were to send matrix output 1, it is going to stop doing that.
Okay,
So now
so
it's
like
off
send
of the
it out the
graphics
outlet.
card, back onto the CPU. So in order to make this work, I'd have to do something like that, but then I'd have to do something different, right? I'd have to say, okay, well, what are we doing? What is this thing? And we went over that in one of the first classes of this, and it's not a general way to work. You usually wouldn't do something like this, although it looks pretty neat. So let's say matrix output 0 here. That's fascinating.
Well, we got a pretty.
I might have to retoggle the jit.world.
Anyway, Okay. All right. So we've got this, and the question is: last time we drew 4 of these, which wasn't a very scalable way to do things. I just kept making copies of this grid shape, and what we want to do instead is to make multiples of this. So there's an object called jit.gl.multiple. We'll stop right there for now. And the multiple thing will draw multiple instances of this shape. It takes at least one argument, right? So, and this is called, so you say how many of them there are, and then you say params, GL params. So what are these? These are basically things like position, scale, and color. There may be maybe a rotate one, I don't remember. But basically, like, position is what we're going to talk about now. We just want to position this multiple times. So now what I'm going to do is I'm going to name this. So at name the shape. And here I can tell this what the target name is. What am I drawing multiple times? The shape. And yes.
I have a question. So you already named your grid space or grid shape my class, but then you have an
No, I did not. I told the grid shape it's drawing to the render space my class.
Gotcha.
Its name is the shape.
Gotcha.
And we may even be able to see that in the inspector. Not sure actually. Draw to my class, that's one thing, and then it doesn't have a scripting name. I don't know where you would actually find this name attribute here. Anyway, you don't need to find that. There it is, name the shape. So you could do this all on the inspector if you don't like this style, but this is a lot clearer to me. Okay, so it didn't draw multiples of it, right? Because it doesn't know where to draw multiples of it. So the way we tell it to draw multiple things is we pass it a matrix of positions. So for each of the GL params, position, scale, let's say, we pass it a different matrix. So we're just going to use one matrix because we've got one GL param called position. And jit.matrix. And let's say we want to draw it in a straight line across the x-axis. So we will say this is a 3-plane float 32 that is 10 across. And then we'll use our jit.gen. Alter this. And we want it to go from, let's say, -1 to +1. So we do our S norm. And theoretically, what is that? Theoretically, this is only happening on the x-axis. But it looked like more than that, doesn't it? It looks like maybe an x and a y. So how would I get only the x and pack that into something that has zeros for the y? Oh.
There's a funny named object that's in Gen that works like a pack that I can't remember, but it's like Squizzle.
So like vector, packs them.
There was something else that you used, or maybe that was the unpack one.
We've got to swizzle stick.
Swizzle, that's what it is.
Swizz the x out of this. So we only want the x. So it's like I said this, right? And so now it's like, well, I'm going to give you stuff on the x, y, and z, or here, just the x and the y. I'm surprised it didn't change.
It's a cloud.
Right. So I really just want the x to go across here. So I pack in the x, and now my y and z are 0. And we do this. And there we have it. Right. They're not really spaced out so great.
And where are you telling it how many shapes are you drawing?
Right here. So a 10x1 grid, which looks like, you know, it's got 10 cells in it. So for each of these, we're moving across, although that, oh, I see. Yeah. So that's where I'm doing it. And then when it comes out of the gen, right, it draws from -1 to +1 across 10 cells. If I wanted to, let's see. So if I wanted to, let's turn on some niceties here. So here I'm going to turn on lighting enable.
Can I ask? So with the positioning stuff that's coming out of the JIT.gen, if you were to scale maybe like the X value up to like something like -10 to 10, would that that work? Would that be something that would work?
Okay, how would we do that?
In Gen? I'm not sure. Let me see.
So here's our X value. Right now it's -1 to +1, right? So we just scale -1 to +1. So what is coming in as -1 to +1 should go out as -10 to +10. And we hook it up. And then it's much wider, right? But we've got this one sticking in the middle, right? Which isn't spaced like the rest. Why is that? That's because this one's still drawing. And if I'm going to be drawing multiple instances of this, and let's say I want to use a param y-axis 0.1, right? And then I want to y-axis $1 float. Move this up and down. We see that 1's not moving, right? That's because it's this grid shape here, which is still drawing. So what you need to do in this method is to set automatic to 0. We don't actually want to draw this one grid shape. We just want to draw copies of it. So now we can move them all.
What does automatic refer to? Like, why do they call it that?
So it automatically draws to the render space. You don't have to tell it to. Normally, well, in other cases, I would have to send it a draw message. I think I just say draw.
Couldn't you use the matrix output parameter so that it doesn't go to the JIT.world?
Well, then where are you going to put it?
To the...
Yeah, I mean, you could output the matrix, but then you're actually taking it off the GPU and onto the CPU, and that's costing computation for no good reason. Right? Like, it's just going to output the matrix, but it's outputting a matrix. So it would work, but that's not a computationally efficient thing.
But so if this JIT.matrix is on the CPU, then it's only if it has GL is when it's not on the CPU?
Yeah, if it's GL, it's not on the CPU, it's on the GPU. So here you see what happens if I turn off automatic and I just draw myself, which is sometimes necessary if you want to determine the order of drawing. You'll have to turn off automatic and then send a draw message to this in a specific order, right? So I might draw this one first and another one second and do my own sort of depth enabling. But that's not what we're doing here, right? So we'll just not draw that. And automatic 1, right, would just draw it based on several configurations. Is depth enable on? Where is it positioned? And that determines which order it's drawn in. But right now we just don't want to draw it at all. Okay, so now we are able to position multiple spheres, which are defined here, right? So if I want to change the smooth shading, for instance, then I could do that here, and each of these will reflect that.
Can you control like the locations of each of these spheres independently from each other, like we were doing previously with the audio visualizer?
Sure. So let's say that instead of moving this y-axis like this, let's say that that I'm going to take this -1 to +1. Let's just get a norm. And I'm going to swizz out the x again. Because remember that we have 10 cells of x, basically. And what I'm going to do here is I'm going to multiply by 2 pi. And you can see where this is going already, hopefully. And I'm going to then take the sign of these numbers. So remember, we're going from 0 to 1, now 0 to 2 pi. If I take the sine of this, then that gives me numbers from -1 to +1 in a curvy shape. And I can let this be the y now. And we get a little sine wave. Right, so controlling each one individually, but in this way where I have to do that in a matrix. Now, I don't have to use this gen to do this. I could have just done it the old-fashioned way, right? I could have said, all right, I've got 4, well, let me just show. So I'm not going to do this anymore. Now this matrix is just going to go straight here, right? But right now it's all full of zeros, so I could say set cell 0, 0, the val, actually 0, 0, 0, 0, 0. The val, we want to put this at -1x and 0y and 0x, right? Actually, there is no. Let's make this 10 by 1 by 1 to be really clear. Right, so set the cell, the 3 planes get set to this. This doesn't even matter. I could have just done about 10 by 1. All right, set the cell, it goes to this.
Dr.
And-
Thompson, can you go back to your gen patcher real quick?
Sure.
2 seconds.
-1 to +1 on the x-axis. Scale it to go from -10 to +10. Pack it in a vector. Take 0 to 1 from the x-axis. Multiply it by 2 pi. Run it through a sine. Let that inform the y-axis.
Okay.
So I'm missing where it's is it because it's a 10 plane matrix that it's getting 10 different x values?
It is not a 10-plane matrix. It is a 3-plane matrix.
Or yeah, a 10
It has
dimensional.
10 cells. So that's important. So let's abandon ship on this. Let me
I get
finish.
the concept of the matrix being 3 planes deep, but then 10 by 1. I just don't understand how it's iterating through it in gen.
Good question. Okay, so here's our cell block again. And I'm just going to take the output of this matrix and plane -1. So we'll see all the planes now, if they'll fit. And they don't. All right. So how does it know in gen, 1, to do 10 spheres, and 2, where to put them? So the way it knows how to do 10 spheres is that there's 10 of these going across, right? Like, if I go all the way over here, there's 10 of them. You just take my word for it. There's 10 cells, 10 Microsoft Excel cells. Each of those cells corresponds to a sphere, right? And this is the position of the sphere, and each cell are the 3 planes, x, y, and z. So each cell, right, in this case, I've set this one to -1 on the x. Let me set it to -10 or -5. That's a little, and I got to hook this up to the matrix, the multiple. All right. And you see that this one moved off 5. There it is. That's that one. The rest are still packed here at 0. What the gen object is doing is like, all right, next, set cell 1. We want to set it to -4. Let's say 3. There's the next one. And next.
So does gen just automate? It's kind of, it's just for matrices. So it's going to go through each cell and do whatever's in that gen.
That's right. So it's, yes. So,
And it
so
would
what
work
it's
the
gonna-
same.
It's doing the
work-
same thing I'm doing here. It's kind of like the Uzi concept, right? It's like fire through all these things, except we don't really have to see that. It just kind of does it all at once, kind of.
Yeah, because I just didn't know like what it's passing them in each cell in one at a time, and it's doing whatever's inside gen.
It's actually passing the whole matrix in. And then inside gen, it's looping through the matrix to
Yeah.
create this and this, right? Or
And
if
if
we-
it was 10 by 10, like we can change the dimensions of the matrix going in, and that doesn't matter.
it does matter, right?
But I mean, it'll still work with gen though, right?
What would happen if I did 10 and 10 here?
There'd be 100 spheres, but I'm just saying they're all going to go through gen, right?
Right, so let's put them through gen, and let's look at what happens. let's look at the output of this. Well, not this. Let's look at the output of gen, and we're gonna have to change gen now, and we'll look at what happens here. So now we'll get rid of all of this.
All but there are 10 identical ones stacked on top of each other, probably. Well, not anymore.
Right, so now we get a cube of them. Or not a cube, a square of them. So let's spread them out a little bit. Right, 10 by 10. Why does it choose to do this, right? Why does it choose to put 10 across this way and 10 down this way? Because if we were to look at our matrix here, we see that from 9 to 9 now, because that's how we scaled it, on the x-axis, -9 to 9. And then on the y-axis, also -9 to 9. Right, so now we have, because we passed in 2 dimensions, across all of those cells, it's going to do now on the x, all of the x, 10x values, and on the y, 10y values, and then fill in that whole grid that way.
So, and then also there's that SWIS-X function and stuff, but what if it's not an XYZ matrix coming in? And what if it's like a 3-plane or a 4-plane matrix? Like,
so that's a good question. So what does happen if we say, all right, just give me this, right? Look at where all the y's are. They're down at -1 or -9. Why is it at -9? Because it tried to normalize across something that has one cell. So if I had a Microsoft Excel sheet and I said, all right, I'm going to give you one cell, count from -9 to +9. You're like, -9? I don't have any more cells to keep counting. That's it. That's all you get is -9. If I put 2 in there, right, it'll try to normalize across from 9 to 9. So now we've got some up here too. If I do 3, now it's going to be 1 in the middle. 4, there'll be 4 evenly spaced on the y-axis. Does this make sense now? What happens if I put some in the z? What do you think?
but what if you put in an RGB matrix to it with 4 planes? What would it even do?
Well, it would throw out the 4th plane. Or I guess it would normalize across the 4th plane, but you won't be able to see that in a...
So Gen can really only work for spatial coordinates then, or it's designed to work with spatial coordinates.
No, you can generate anything, but now we're getting into the other planes of the matrix, which are more complicated.
Yeah, is there like a SWIS R if you're sending an RGB?
Sure,
matrix?
you can do the SWISs different ways. So they're all the same though. So for instance, so let me just SWIS out the X here. Let me do it after this. So SWIS out the X, and then I'm going to pack it back up. So this doesn't do anything, right? It's just to prove a point. Let me SWIS out the Y. But here I'm going to say this is G. And here I'm going to SWIS out the Z, and I'm going to say, well, this one is 2. 0, 1, 2. It doesn't really know. Well, I only sent in a 2-plane matrix. Let me send in a 3-plane here. Cell block is panicking. Make sure I did this right. So these are the same thing. Sorry, that's not working like I want it to. I'd have to think about it. So G is the equivalent of Y. Maybe it's not here. Maybe if it doesn't get a 4-plane matrix, it doesn't like that. But maybe more generically, it's just calling them 0, 1, 2. Right? Here, there's just a convenience naming. for
Well,
what
we
they are.
couldn't do Swizz ABC, and we couldn't do Swizz. I don't know. We couldn't use words, right? We'd have to.
Really, probably the best technique that's most generic would be to use just which ones are you talking to. But this isn't very descriptive, right? So for me, I say, well, that's the X, and that's the Y. But these are not things that I'm making up. These are things that are hard-coded in the Swizz, right? And I don't think that it's going to allow me to... Yeah, this doesn't seem to work. But on a color matrix, you can do that. Maybe it's just best to stick with either X, Y, Z or 0, 1, 2, and then you can do 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Anyway,
I have a question.
Yes.
If you wanted to do what you did last week with controlling each sphere with a different band of audio, how do you get into control each individual sphere?
So you would have to set a matrix so that each individual cell is set. So each individual cell corresponds with each individual sphere. So let me jump to something a little more like that, or a little more complicated, which I'm hesitant to do, but I'll do it, just to show a demonstration. I don't think I'll have time to explain what's going on here.
Doesn't setting the cell just put the sphere in a new cell, though? You wouldn't be able to gradually move,
You'd have to gradually change the cell.
and that works.
Yeah. I mean, that's what these are, right? Is like if we looked at the cell block, we would see that, you know, this one is positioned. This may be a cell 2 or something like that, and it's positioned at a certain place. You just change what's in the planes of that particular cell. So all of these cells, you know, they are still, until I change it, they're all in those cells, and they're located. There's 3 planes in each cell that say where each of these spheres is supposed to be. Yeah, and I'm having, I don't know why. Let's see. So trying to figure out what might be confusing about that, because to me it's like, oh yeah, I just said it, so it sounds easy, but maybe it's not. So let me, well, before I move to showing what Andrew's talking about, maybe an example of that. I wanted to introduce something that's pretty handy, and that is the notion of a camera in this space. So jit.gl.camera, it's convenient to put it inside that render space. And you can position the camera however you would like. But most of the time, to just skip to the chase, we're going to have an enable message. And what this is going to do is it's going to, well, we can look at the help file for this. So over here, there's a little setup that allows us to use game style controls. So W to move forward, S to move backward, that sort of thing. And use the mouse to turn. And it says mouse click on the display window to animate this camera view with the UI listen enabled GI anim drive object. So we have to use this enable attribute, and we use this attribute, and it's handy to have this one. I'm glad those are spread all out. Okay, so we enable this. We use this anim drive thing, which just pretend for a second that you know exactly what that is. So this is just something that is used for animation. And this anim reset will let us escape in case I really do this badly, and the chances are pretty good because I'm not good at this. So now if I want to, I can move backwards in the space using my keys, and I can click my mouse and kind of look around, which you guys will be really great at. And there's what happens to me. So I need to reset that. And there's certain things we can control about this animation, like the speed maybe is a little too high for me. So I'll reduce that down. And now I can move a little slower through the space.
So I guess the only difference between this and like GL handle is GL handle's showing you like the actual graph, and this is just like moving around the.
Well,
Most
handle is
cases.
moving the object. So instead of moving the world, I'm moving through the world. I'm moving a camera around,
Okay.
right? This is still located at the same place.
This is Minecraft creative mode.
Is it really removing the object in the case of GL handle? Because like I don't
Yes.
know. It just wow. Yeah, I guess that makes sense, but it does not feel like that at all.
Well, let's do
It
that.
sends out a
Let's-
position message,
That's
right?
right. So jit.gl.handle does just simply position the object it's attached to. It sends
Well,
out
there's
a
nothing
message.
to relate to it moving, right? Because if you have multiple objects around it and you want to move it, then you probably see handle.
So here I can move the objects, and I can
Oh,
also
I see.
I can
Okay.
also fly around it at the same time, right?
Okay, that makes sense.
So here's a camera looking at a moving object, right?
Okay, that makes sense.
All those chickens.
All those chickens.
You know that at some level this is very basic, but I just want to highlight like the fact that there's some computer that knows how to do this very fast.
Yeah, it's amazing.
Yeah, right?
This is
Oh, yeah.
incredible.
On the graphics pipeline. Okay, so I wanted to get to that, but also let's also be able to change not only the position, but the scale of each object individually. Right, so now we've got two parameters we need to deal with. If you don't feed it this scale matrix now, it's going to be unhappy and you won't see anything. So we have to make another matrix that's supposed to be the same size. So let's use our same configuration here. What is this doing? We don't want to do any of this. So let's just scale all of these equally from what's going from 0 to 1. Let's make it go from 0.1 to 0.56. Okay, so now on X, Y, and Z, because we have this 4 by 4 by 4 with 3 planes. So each cell that corresponds to each of the positions is going to have an individual scaling. So we'll run this into here. And, oh, it looks like, yeah, and it's kind of funny because if we look at it, it scales things unevenly. Why does it scale things unevenly? Can you see what I'm talking about? So look at them. Those are scaled differently on the X, Y, and Z. Why?
I think it's because it's trying to make a projection in 3D that can't really be represented in 2D.
No, it's really the case that these are being scaled differently on the X and Y and Z. Right? Why is that the case? Right? And if we look at the jit.cell block and we imagine what's happening here, this won't work because it's 3D. Okay, well, the reason it's happening, I'll just say the words, is because remember that we're going from 0 to 1 across 4 cells, and then 0 to 1 across 4 Y cells. So as we go down here, we get 0, 0, all the way down to 1, 0, right? So if you imagine scaling this first row, the bottom one's scale is 1, 0, something, right? So we've scaled the X to 1, but the Y to 0. That is not even. If we wanted to scale this evenly, how could we do it? So in other words, I want these to still remain spheres.
Would you have to throw a 2 pi in there somewhere?
No, I mean, that would just do it differently. So I guess here is pretty tricky. And let me just tell you the answer is that, well, what if I just used only the X, which is going from 0 to 1, right? And I say, okay, well, just use that then. And we're going to make it clear. Now, all 3 of my vectors will be scaled the same way. Sorry, all 3 of my dimensions will be scaled the same way. So this vector is X, Y, and Z. And there that looks a little more like what I was going for, right? So if I wanted to change any one of these, So I could put this, I guess, just a one-time deal. I could throw it into this matrix and bang it, and then I could change it that way. Right, I could set any of these I wanted. Or I could have gone through the trouble of making an Uzi that sets these, in the way we just did with the mesh, right? So jumping from mesh to this is the same thing. So instead of drawing points in a mesh, we're drawing locations. And it actually allows us, because it doesn't have to be stitched together, it allows us to define things in 3 dimensions. Okay, so extrapolating from that a little bit, well, what if I decided that I would like to organize all my spheres in a sphere? Because I heard you like spheres. So what I could do is I could say sphere, and let that define my positions. There they are. It's a little small. So let's say, and I don't know if this is, looks like me, I don't know what it is. So let's say scale -1 to +1 goes from -9 to +9. Right, and there's my 4x4x4 sphere, not enough dimensions. And in fact, it only uses 2 dimensions to create this. So let's do, what's 4 times 4 times 4? 64?
Yes.
Let's do 10 by 10. No, let's do, well, this doesn't matter anymore. So we can just do, yeah, we'll do 10 by 10. And just to make it clear, we'll do 10 by 10 here. So now we have a sphere for our locations, right? So all the points of a sphere become points where we put spheres.
Dr. Thompson, I have a quick question.
Yes.
How did you get your jit.gl.multiple to have that second inlet? Because right now I only have the one.
I have to put 2, and then at GL params, which one's
Okay.
And this, I can't really tell where I am, so let me reset my animation here. Yeah, and that looks somewhat correct. So it's centered. How would I crossfade this sphere with a, I don't know, with what I had before? So let me back up here. Will it let me undo? No. How would I crossfade this sphere with, let's say, a, I don't know, is there a cube in here? Nope. Plane. So how would I crossfade between these two things? Interesting question. And I wouldn't necessarily expect you to know the answer. I don't remember if we ever did this, but there is an object called mix. And it says I'm going to mix between these two things. And the third inlet is my mixing factor. So 0 will get me what's here, and 1 will get me what's here. So I'll make an argument into this gen, as you may remember.
That's like reverse of most max objects where the first inlet controls things.
Yes, and I make that mistake often, actually. So I'm going to set this crossfade at first to 0.5. And using param, remember, allows me to pass in this argument from outside of the gen. So now we've got somewhere between a plane and a sphere. And to make it a little bit more dynamic, I can say xfade, because that's what I called the parameter. And I can change this to go from sphere to plane. Like this, right? And if I go beyond, I actually get pretty cool shapes too.
Whoa.
And if I wanted to, I could, use some sort of audio object and snapshot it. And let that control this crossfade. And then I can use my camera to kind of move around it. I'm not very good at this, I apologize. And I got a handle on there too, that's annoying. Okay, so there we go. Yeah, inside the dynamic object.
I have a question. What is the rate that the JIT world bangs?
It depends on what you've set for FPS. So let's take a look with JIT.FPS GUI. And we'll look and see what it's doing now. It is doing unclear. Let's do at FPS 60. And it'll try to do 60. It may or may not be able to actually do it. Yeah, so I think it's set to 60, but it is struggling to keep up. Because I'm drawing 100 spheres in this space. Isn't actually that much. But these spheres also have lighting enabled and smooth shading on and all that. So, okay, we could also change the color of each of these. So let me change 3 here. We'll have a color matrix as well. And let's use JIT.noise. 4 planes for a color, float 32, believe it or not, and 10 by 10, maybe. We'll see what that does. And I need to send this here. Right, so now it's flashing a bunch of noisy color at us. Maybe not the best idea. I could try to smooth out this noise. Maybe bank it only every once in a while to change it. In fact, maybe I should just stop. You know, and now it's frozen with those colors. It's Skittles.
Taste the rainbow.
Taste the rainbow. All right. Well, that's all we have time for today. I had a whole thing worked up, which is pretty exciting, actually. So I'm going to show it because... Okay, and turn this down. And so what we have here is we have the ability to kind of see digital harmony. I'll just leave it at that. And let me turn those off and turn these off. So here, let me change this erase color. Right, we have 3 different tones that are being used for the X, Y, and Z. And I have different intervals here I can specify. Right, so this is a 4th and a 5th maybe, or I can't hear the fundamental.
I don't hear anything.
Oh, I know why.
Sure, yeah.
No, it's always this one. You got to do an additional step in Max where you choose this. It's really compelling. Okay, so there's the audio. Hopefully you hear that now. And we can explore things like, well, what happens when we go slightly out of tune? And right, or what happens if we're in tune, and what happens if we change our intervals here? 5/4 is a third, believe it or not. So we can look at these different things. I don't know why these are the same. Oh, I see. I don't want those to be the same. Okay. And then we get this shape, and we can go out of tune and sort of look at what John Whitney would call the tension and release of shapes. Right, so we kind of found something close there. close to harmony, but if we find the exact harmony, we get more still. I'm rotating this image here. And as we become more dissonant, it'll get wobblier. Right, so here we have some beating tones reflected. And then we can, of course, add feedback and get all wacky because that's necessary. And if we reduce the size of these to something small, it gets pretty cool looking shapes out of these sounds. So this is a little feedback going on to enhance all the curves. And we can get this sort of shape. This is nice. Yes, Allison. Oh, did you have a question? Sorry.
Oh no, I'm sorry. I was doing something. I was doing something on my end too. Sorry.
So I put this up on Folio along with the abbreviated one we did in class, or something very similar to it. You can study this, but basically the only thing you don't know here is the catch object, which just takes an audio signal and is going to turn it into 3 planes of a matrix. So here I've got the frame size set to 1000, so there's 1000 spheres. And I just arrange them using the catch. And there's some trickery here, but that's basically it. We're not even using the gen object here at all. Instead of gen, we're using catch to generate the information for a matrix.
Wow.
Okay.
That's cool.
It's fun, and it's not very hard. You know, this looks complicated, but that's because I wanted to do some fun stuff with crossfading and all that, and really is not actually necessary. Most of it comes just from simply visualizing the 3 different tones here, which are just simple waves. You know, if you were to put some sort of music in there, then that looks a little bit different. So we'll send this as the X and the Y for fun. Right, and I really want to turn this down, so. Right. Basically, a least as you figure is what they're called. Yeah, it's fun. Okay. And with that, I mean, I could go on and on, but we only have so much time. So there it is. I will look at your things you turned in. I will send out the midterm review sheet. Right now, it's kind of sparse. I'll send you the one I have currently, which tells you what's going to happen, and then I will consider fleshing it out with more detail. But my thought is that you have all those class notes. They're all on Folio. So the proper thing to do is to go through and study the class notes. And what you should be, and I'll send you the exam review, which tells you, you know, what it is that you should be trying to ascertain or discern. But like I said, I want this to be take home. So to an extent, it's going to be just finding the information if you don't already know it, which will just cost you time and not points. But for instance, if I said, you know, there's a quote from a person who talks about when they went to IBM and they were interested in taking their analog computing into the digital realm, you should know who I'm talking about. Or if I say, this person talked about their interest in controlling visual parameters of a hybrid computer system expanding on their Groove instrument, you should know who I'm talking about. Or if I say something like, you know, this person made a machine that read drawn notation in Paris, France, that's the UPIC, you should know that's Xenakis. If I say all those sort of things, you know, these concerts featured, We're in a planetarium in San Francisco and featured multiple projections. You should know that's the Vortex concerts. Just basically all the stuff we've done. I am inclined to, but will not, ask you to answer things in longer form, which is what I'm actually really interested in you knowing. It's just a lot harder to assess that. So for instance, I'm more interested in hearing your opinion about why it is, like where does John Whitney fit in the scheme of a visual music narrative that focuses on a musical scheme, right? Or why is the work of or how does the work of John and James Whitney tie into Oscar Fischinger and Norman McLaren's ideas about sounding ornaments or drawn sound? How did they approach that, right? I'm more interested in that sort of thing, but I'm not going to ask you those sort of questions. So it'll be short answer or fill in the blank, mainly fill in the blank, or maybe multiple choice, probably fill in the blank. And then there's going to be a set of max questions, which basically if you were able to do the tasks, you should be well prepared to do these, but you will have a week to do them, maybe longer. So if I assign that, so I'm going to assign this on Tuesday of next week, and it'll be due after spring break. So if you're clever, you will do it before spring break. If you like torture, you will just not do it before spring break. And then it'll be due the Tuesday following spring break. So Tuesday of next week, I will deliver to you the midterm exam, and then 2 weeks from then, it'll be due.
Sounds good.
Okay.